OSPFv3 instance ID. In this video, I am going to talk about the OSPFv3 instance ID functionality in the OSPF version 3. You know that in OSPF version 2, we can configure OSPF on one interface. And when you are configuring OSPF on that interface, OSPF is sending hello packets. And when this hello packet reach to other routers, after the hello, for example, exchange and verifying the information in the hellos of two routers, for example, multiple routers, we have neighborship between them. But in the OSPF v3, we have a new field. We call it instance ID. Okay, instance ID is useful when we are trying to, for example, forming neighborship. Okay, in multiple instance in one link. Look at here we have one link. This link has four connected routers. We can configure the OSPF v3 on the fast Ethernet 00 of R1 and router 2 and router 3 and router 4. If you configure OSPF, by default all of these four routers are establishing the, for example, neighborship with each other. This is the default behavior. In some cases, maybe you want to experience the, for example, neighborship only between the router 1 and router 2, and also, for example, router 3 and router 4. You can do it by the help of instance ID. Let me to show you the configuration. Look at here. On the interface fast Ethernet of router 1 with OSPF v3, we can configure OSPF v3 1 IPv6 or IPv4. Then area quad 0. This is the command that we are using it for configuration of OSPF version 3 on one interface. Then here you can use instance, then for example 1. Okay, on the fast Ethernet 00 of router 1, we are configuring this command, and also on the fast Ethernet 00 of router 2, we are configuring exactly same command. But on the fast Ethernet 00 of router 2, we can configure OSPF version 3.1 IPv6 area quad 0, instance ID 2, and here instance ID 2. After that, when the R1 sent its hello, and also R2 sends its hello, and also R3 and R4, on the hellos of each router, we will have instance ID. Only routers that are sending hello with the same instance ID, okay, establish neighborship with each other. Actually, we can say that one of the neighborship conditions is the same instance ID. This is useful when we are forced to connect all of the routers into one broadcast multi-access, but we don't want to have neighborship between the, for example, routers. Let me to show you. It is so simple, and you know that this is beyond the scope of this class. Only we are informing about this for our more knowledge. Look at here in the router 1, conf interface fast Ethernet 00. Let me to configure IPv6 address 2001 db8 1, okay, 2:1/24 that's it, and then no shutdown. This is the R1 configuration. Router 2, conf interface fast Ethernet 00 IPv6 address 2001 db8 again 1:2:2/64. Okay, here on the router 3, conf interface fast Ethernet 00 IPv6 address 2001 db8, for example 1:2:3/64, and then no shutdown. Okay, and after that on the router 4, let me to configure same command, interface fast Ethernet 00 IPv6 address 2001 db8 1:2:4/64, and then no shutdown. Now let me to configure OSPF v3 on the router 1 IPv6 unicast routing, router OSPF v3 1, okay, and then router ID is quad 1. Okay, and after that interface fast Ethernet 00. Here I'm going to configure OSPF v3 1 IPv6 area quad 0, then instance 1. That's it. Let me to show you the hello that now R1 is sending on this interface. By default, the instance ID value is 0, but now we are sending the instance ID as the, for example, 1. Here we should find one hello packet. This is hello of the router, for example, 1. And here in the instance ID, we can see we are sending the value of 1. Okay. After that, in the router 2, let me to show you what is happening in the router 2. First, IPv6 unicast routing, okay. Then router OSPF v3 1. After that, router ID is quad 2. On the interface fast Ethernet 00, I'm using this command OSPFv3 1 IPv6 area quad 0, but I don't configure the instance ID. Okay, after that, let me to find the hello of the router 2 OSPFv3. Look at here. This is the OSPF. Here we can see the different hellos, but here we have hello only. Look at here, this 8.0.1 received from the router 2. This is for router 2. And here, as you can see, instance ID is 0 because of that we don't have any neighborship. Okay, let me to remove this command. After that, we can use this command OSPFv3 1 IPv6 area quad 0, and then area first instance, then 1. Now we will have neighborship between these two routers, router 1 and router 2, as you can see. In the router 3 and router 4, I'm going to configure similar function, router OSPF, for example, v31, router ID. First, we should enable IPv6 unicast routing, then router OSPF v31, or okay, router OSPF, then v31. After that, router ID is the quad 3. Then over the interface fast Ethernet 00, we are configuring OSPF version 3.1 IPv6 area. Then, for example, it's called a quad 0. After that, instance 2. And then between in the router 4, IPv6 unicast routing, router OSPF v3 again 1, router ID is quad 4. And then over the interface fast Ethernet 00, we are configuring OSPF version 3.1 IPv6 area quad 0. Okay, quad 0. And then here we can use the command, for example, instance 2. Look at here, now we will have neighborship between the router 4 and router 3 after some second. And after that, we will see the neighborship. But before the neighborship, let me to show you the different instance ID that we have. This is here we have instance ID of 1 and 2. Okay, this is for the let me to stop it. 800 received from the router 1. This is here we can see the instance ID is 1. This is received from the router 3, instance ID is 2. Then router 2, instance ID is 1. And let me to find, yes, this is for, received from the router 4. Okay, as you can see, the instance ID is 2. Okay, until now we didn't have neighborship. Now we have neighborship. Router 1, check the neighborship between the router 1 and also router 2. Show OSPFv3 IPv6 neighbor. Okay, we have neighborship with only router 2. And here show OSPFv3, for example, interface of IPv6. Okay, IPv6 interface fast Ethernet 00 can show us that the fast Ethernet 00 is up, line protocol is up, link local address. This is the link local address. Interface ID is 3. And then area is quad 0, process ID is 1, and now you can see the instance ID is 1. Router ID is quad 1 in the router 1, network type is broadcast, cost is 1, and then state is DR, priority is 1, DR is quad 1, BDR is quad 2. This is the link local address of the DR, this is the link local address of the BDR, and here we can see the timers of the OSPF, hello time, dead time, wait time, and retransmit time, hello due in 9 seconds later. And then here we have some other information. Okay, also let me to show you the status of router 2. Show OSPF v3 IPv6 neighbor. As you can see, the router 1 is the DR, router 2 is the BDR. In the router 3, show OSPF v3, for example, IPv6 neighbor, can show us that the router 4 is DR, and the router 3 show OSPFv3 IPv6 neighbor can show us the router 3 is BDR. Actually, here we have one DR BDR election. Here we have another DR BDR election. This is the header of the OSPF version 3. Version is 3 type, and after that packet length, router ID, area ID, checksum, instance ID, and then this is reserved. As you can see, the number of fields in the OSPF version 3 header is lower than the OSPF version 2. Alright, in this video we have learned about the usage of the instance ID, the new field of OSPF. Now let me to talk about the OSPF version 3 authentication, and we will compare it with the OSPF version 2 authentication, but we will learn about them in the next video. Now it's your turn. You should review this scenario, and after that you should configure this scenario, and then please come with me to the next video. We will learn more than this about the OSPF version 3 and specifically on the authentication and also encryption of the OSPF version 3.